This is MS600, the second module, talking about interacting with Microsoft Graph. Now, Microsoft Graph is one of data sources that implements the ODATA standard, ODATA 4.0. So today, when we design REST web services, so let's just make sure we understand the backdrop of it. Okay, REST tries to model remote resources. So our HTTP request is used to interact with these remote resources. The API provider gives us various web services or APIs that we can invoke in order to manipulate the remote state of these resources. Now, from the concept of REST, there is one very common universal activity. Now, that universal activity is to interact and query a collections of data. Okay, because after you start developing lots and lots and lots of REST services, you start to come to realization that many of the services you design are just proxies to a collection in the back end. So to that end, why don't we formalize some notions in terms of querying a collection of data? Now, there are some common vocabulary when it comes to query collections of data. For example, anytime we talk about collections of data, we may want to filter the collection so only the record we want comes back. Projection. We may not want every single property of that data source to come back. If we're not going to use all of the fields, asking for all the fields is a waste of bandwidth. So the projection allows us to focus and narrow down exactly what data we want. Order. We may want our data to be sorted in a certain order. Skip and take. Skip and take. So these are typical things you would do against a data source. And naturally a count. Now, it depends on the underlying type of sources. They might have related entities that you can expand from. Now, take a relational database, for example. You may have a parent record expanding to child records. So OData is this specification that allows us to express our intention against a collection of data using HTTP query strings. So in this lab number 2, we're going to start by showing you how to query the Microsoft Graph using the OData syntax. So everything we'll be talking about is based on the OData syntax. Just a side mention, there are other technology that designed to address the same concern. For example, GraphQL. So both of those technologies out there trying to help us query stuff remotely, okay, without doing the things that we used to do in the XML days, where we got to write a method for just about everything. All right. So for this exercise, we're going to start with the Microsoft Graph Explorer. Now, you don't have to sign in per se. Most of the query we will run will be fine with the sample data. Now, later on, we're going to run a query that is going to access Exchange mailboxes, and I don't think the sample data has any attachment to speak of, so I might have to sign myself in at that time. All right, so here is the Graph Explorer. You can certainly Google and search for Microsoft Graph Explorer. You don't need to sign in. This is where your OData query goes into. Now, if you're interested in OData, the best way to learn it is odata.org. Now, OData is according to this, is the best way to query REST data source. I would not say this is how you write a complete API, but it's certainly a way to query a collections of data. Now, if you want also quickly learn about the various OData tools, you may want to download a Postman workbooks. All right. So there are Postman tutorial collections that you can import into your Postman and start going over some of the common keywords. It's not a lot of keywords. If you have used SQL in the past, this should be pretty just direct translation for the most part. All right, so what makes this a little different in terms of OData is that every remote collection has an endpoint. So the very first endpoint we're going to show you is this guy here. Now you may also notice on the left side of the screen there's plenty of getting started sample code. So feel free to take any one of these. There's, for example, OneDrive. You can just say show me all the items, and notice each one of these correspond to an endpoint which represents a collection of data. All right, so if you're interested in Outlook calendars, get events. All right, so this calendar view, when is the start time, when is the end time. Okay. All right. So there's plenty of sample graph, not graph query, a sample OData query on the left that you can use to practice how to, or you can use this as a reference to see what is the endpoint to this type of data that Microsoft hold for you. All right, so the first query we're going to try is this collection. So if we break this down, it's quite obvious that we're looking for some kind of groups, right? So here we're going to get every single groups to come back. All right, so this is all the groups there is. Okay, and remember this is a sample data. This is not your data or my data, it's just some sample data here. All right, so remember projection, filter, sorting, etc. We're going to start with projection. Projection means let's limit what comes back to only the field that we're interested in. Okay, we don't want to download all these data that we're not going to make use of. All right, so we're going to use query strings. The keywords start with the $ select equals comma separated column values. So you can see that we have a bunch of different columns. Okay, so for example, display name, I would like to see display name. Comma, I would like to see mail. And I would like to see visibility. Now when you run it, okay, you're going to see the exact shape of the data you want that's returned as a JSON object. Okay. Now there's a data context that tells you how do we get this answer, where do we get this answer from, okay, and an array of object values based on your projection criteria. Now folks, remember this is not public stuff. We're using a demo set of data, so we can certainly see these fake data. But if you want to access your own Azure AD groups, your corporate pieces of data, you must obtain an access token. Now in the first lab, we talked quite a bit about authorizations, authentication, and so on. Now, a party must be granted permission to this Graph Explorer, okay, in order to obtain the access token to access these REST calls. So connecting this back to Module 1. Remember in Module 1, we talk about how that app is granted API permission and how that API permission, once granted, allows the app to obtain an access token. And once the access token is received, we're able to access these various endpoints. All right. So next, we're going to run a few additional things, such as, let's say we want to add additional field. We can just append to the end of that. So comma ID, for instance, will give us additional column in the results. All right, so that is projection. Now let's say I want to sort by display name for any reason. I can use an ampersand to introduce the next keyword. The next keyword is order by. So what exactly do you want to order the results by? Okay, order by equal display name. All right. So now the result is sorted A to Z alphabetically based on the display name. And you'll notice this is a sorting by ascending order. If you would like to reverse that sorting order, you can add a descending keyword to the end. Okay, so with that descending keyword at the end, it's sorted in descending order. Our next activity will be filtering our data. So we're going to start with HTTP as an access messages. Now, when you copy and paste this, make sure that there is no spaces before the HTTPS. Now, we're going to see a bunch of messages. Now, like I said, most of the all of these email has no attachment. So instead of using the has attachment, I'm going to use this field called is read. Okay. So here I'm using the filter at the filter query parameter filter equal. Now notice in ODATA when it comes to equal, not equal will be EQ and EQ, LT for less than or LTE for less than equal to. Okay, so the filter is read equal true means I want only those email that hasn't been read. Now, it is also possible to combine multiple criteria. In this case, I'm looking for message that I've read and does not have an attachment. Okay, so this is, notice the end, I can combine two conditions into a single evaluation. Now, for some more interesting query functions. So in this case, filter starts with, now that's a function that says, for the subject field, I'm looking for all the subjects that start with the word my, my. All right, so when you run this query, you'll see only messages where the subject begins with my analytics, and so on and so forth. And of course, we can combine this, ampersand. Remember how to project, select equal subject. All right, so that way we don't have to sift through all the emails. We can just straight away look at the subject. Okay, so naturally they all start with my. Okay. Now another interesting way to filter your records. Now let's suppose we have child nested properties. So for instance, I'm going to use groups instead of message this time. Now, when we look at groups, remember the extra space in the front? Yep, that's that. So when you look at this groups results, and you'll notice that group types is not a single value. Rather, when you see that square bracket, it tells you it's an array. So with that array, there can be multiple values. So how do we look for the existence of a value within a collection? So here's a syntax you can use. So this reads, go into the group types, and it's going to be an array. Now, if any of the item in that array satisfy this lambda expression, okay, C can be anything you want. So basically, given an item, if the item equals unified, so that is our filter against the child items of that group type array. So if the group type contains three things, if any one of them is unified, we would like those results to be returned. That's what this query means. So you find group types. Now within this sample set of data, I don't see any group with multiple group types, but the idea remains true. If you have a property which contains an array of multiple objects and you would like to test any one of them in a specific value, you can use this syntax. Next, pagination, top and skip. Top and skip. Now it depends on whether you've seen these SQL syntax, we have take and skip as well. So this gives the top 5, the first 5 records. All right. This next query will give us the second page. We'll skip 5 records and we'll take the next 5. Now notice there's also a link to the next page. So if you take that, that will give you the next page. Okay, so we're in page 2. The next link will take us to page 3, where the page size is 5 records. All right, so the next set of queries, in order to see this filter equal has attachment equal true query, I signed into my own personal Outlook account. So here, filter equal has attachment equal true. This will return all the emails that has an attachments. So there it is. So they all have attachments. Now the next one, I will expand based on the attachments. Okay, so if you scroll down this email, you're gonna find here are some attachments somewhere, has attachment equal true. And it's great, we know that it has attachment, but we would like to be able to expand on it. Okay. So our next query will say has attachment equal true and expand related attachments. All right, so now the query comes back. We should be able to see it's the same email, but here is the related attachments. Okay, so there may be one or more attachment that has been expanded to include those attachments in this query result. All right, and these, once you expand on an entity, keep in mind the graph, Microsoft Graph, let you project from these attachments, but you cannot filter by these attachments. Okay, so once you go to expand, you can further customize it by saying I would like to project only 3 fields. Now, if you're using this Microsoft Graph interface, be very careful about this equal sign. It doesn't like you to put equal sign within that parentheses. Okay, so I'm going to use URL encoding equal sign %3d instead, and this will return. Well, it's kind of fall off the edge. So make sure you select equals ID, name, content type, size. So when you get to the attachment section, all right, you'll see that you're only including ID, name, and content type in the email. All right. Now we can also use this keyword called count. Now this keyword count will naturally, okay, this will naturally tell you how many queries, how many email you have in your mailbox. All right, so there's 2,640 emails. So there's that. Now you can combine this with other criteria too. So here, filter is read equal false. How many messages within my mailbox are things I haven't read? So 323 hasn't been read at all. Okay. Now you can then also use this to search for keywords. All right, so these are the keywords you're searching for. All right, so these are somewhere within the message, you will find the keyword business. All right, so that's one way of doing it. This will limit the search to the subject field of the email. All right. Now this concludes this lab of query Microsoft Graph. Now to wrap everything up, why are we doing this? because what Microsoft holds for us is our information, is our data, our mails, our photos, our calendars, our contacts, our projects, so on and so forth. The best way to consume this data is to use a commonly agreed specification. So Microsoft can focus on providing the ODATA data source. Other people can build client apps. I can build an Android app to display your calendar appointment. I can create a console app that access your email. I can write a website that go through your contacts, that go through your online Excel. Now, this is how we consistently interface with the data that Microsoft offers. So this technology called Microsoft Graph. And through this Microsoft Graph, graph.microsoft.com, we can owe data into their data source. Subsequently build applications that interface with this data. Compared to the old days without the ODATA, without the graph endpoint, how do we actually get, say, SharePoint data? Well, back then it's all XML over HTTPS, and we have all sorts of custom libraries. The trouble with custom library is if Microsoft only gives you a .NET library, that's pretty much it. You got to be building your client with Microsoft.NET. And if there is no well-documented, consistent way, every product is going to have their own library. So you're going to have to imagine working with Exchange, you got to learn a library. Working with working with Office, you got to learn another library. Working with SharePoint, another library. Now, none of these libraries will work with any consistencies if they are developed at different time period with different technology in mind. So with this approach, all of Microsoft's data, whether it's Microsoft Dynamics, Office 365, Azure AD, they're all exposed in the same OData format. So it makes it much easier to build application that consumes them.